So this is the giant crossbow that was designed by DaVinci, Leonardo, back around 1883. And as you can see, it was massive. So this was my giant catapult I was building. And it was going to be used to hurl my near space plane, my rocket jet near space plane, into the air to give it its momentum. And as you can see, I could elevate this thing from being horizontal to about a 60-degree angle using hydraulics. And the interesting thing to consider is I built this whole thing, just like everything else I've ever built, by myself. I cut out all those steel parts with my plasma cutter. I calculated all the bearings and the load surfaces and everything in my head and created this pretty cool catapult. And this here was the little captive truck. I call it a truck. As you can see, it has a whole bunch of rollerblade type wheels, polyurethane wheels with bearings to keep this thing locked in place. You can see there's lots to see. There's 8 wheels on top and 2 on each side on the outside and 2 on each side on the inside. And this is the part that the rocket jet plane would sit on. And this truck would be attached to the ends of the carbon fiber bow. And there you can see there's 2 hydraulic cylinders, one raised up the lower portion, and then the red cylinder raised the upper portion. So here now I'm turning on the hydraulics. And you can see at the very back end of this thing, that winch that was designed to cock this thing. And now you can see how nice and smoothly this little truck travels up and down the rail. Actually, it really worked superbly. I was amazed at how nicely it turned out. Yeah, it was a lot of work. And of course, just like all the things I build, I had to have this thing powder coated. Here you can see I've only got the upper portion built or powder coated. I was still working on the bottom portion, so it wouldn't be ready. That's the business end where the bow would attach. The bow is built in 2 12-foot sections attached at the front, and they could swing back parallel to the body of the catapult for transport. So you weren't driving down the road with this big 24-foot wide bow. And there's my generator. So this thing was off grid. It carried its own electrical supply, everything it needed to function. And it was really cool. So to build the bow, I had to build this mold that was 12 feet long. It was 14 inches wide, and it was about 8 inches deep. And I laid up the carbon fiber material lengthwise. And at the root where attached to the catapult, it was about 4 inches thick, and it tapered all the way down to a little over an inch thick out at the end. And as you can see now right here, that's my oven I'm raising. That thing was insulated. I could lower that right down over the mold as I was molding the parts. And then by using my propane jet heater on one end, I could heat it up inside there to an incredible amount of temperature to cure the epoxy resin. In total, I had about $6,000 worth of carbon fiber and epoxy resin in this thing. So once you've laid up your crossbow, you put all your layers of carbon fiber down, you've put all your epoxy on it, Then what you do is what's called vacuum bagging. Now you see I've sealed the whole thing in plastic, and that tube on top is connected to a vacuum pump, and what that does is sucks out every little bit of air. Because air kills laminations. You never want air gaps when you do carbon fiber or fiberglass layup. And this here obviously was a little space plane that I was working on that was going to get launched off of this device. It was pretty cool. It was all made out of high density foam and then overlaid with carbon fiber. And there's the look. There's a look at it as it's coming along. Here it is coming along even further.
Step is to spool up the two turbines inside. Once the turbines are running at full speed, then you fire the pulse line. By the time I leave the 32-foot launch rail, I should be traveling about 40 miles an hour at that point, so I'll immediately have stability and the ability to maintain control. And it's going to continue upwards at a 80-degree angle. We'll shut down the pulse jets. The initial momentum I have gained will slowly begin to diminish until I reach the apogee of the flight.
The Viper spaceplane will glide into suborbital space for approximately 8 minutes before gravity pulls it back to Earth.
In a later date, I was going to use it to launch base jumpers off of mountains, just like launching Superman.